let's see, can I, yeah, okay. Um, okay, anyway, this is how this damn star foiled our Station 3 Josephina observation on July 10th. Um, so anyway, um, we got to the site. We had set up two other remote stations for this occultation um, on the way to this place called Myersville, Maryland. And in Myersville, we arrived there about half an hour before the event and set up the telescope. And there was this nice asterism called Terabellum of four, fourth magnitude stars just south of Saturn that were as close to the pre-point line at the time we needed. The time of the event was 5:50 UT, and you see this is about 20 minutes before. And so, so I managed to get our scope going, a few minutes or several minutes before the event. And this was using a Maxi system. And this is a screenshot from the video taken, as you can see, about a minute before the occultation. When I was trying to figure things out, I'd actually acquired this field before, but there were these two bright stars and a few medium brightness stars near them, and they just didn't match the charts. I was looking at these two. They should, the camera would be rotated a little bit, but I just couldn't match anything and was fishing around trying to find something that agreed, but ran out of time. It turned out I was actually landed on the target field and stayed there for about 10 seconds, 15 seconds or so, and decided it wasn't the right field because there was another star that was too faint on the target star field chart that confused me again there. But anyway, this is the couple of nights later, the mystery was solved when I made a recording with the RunCam camera on a Mighty Mini and of the Terabellum star field. And here are the four Terabellum stars, as nice as possible. But there was a fifth star there, V1943 Sagittarii, which showed up, but it only appeared as 8th magnitude on our charts, much fainter than these others, so I didn't notice it. If I'd had more time to study the field, I would have figured it out, but when you're short of time, pattern recognition, quick pattern recognition is important. The other stars are about 4.5 magnitude, and this star is about 5.5, as you can see, according to the camera. It's a red spectral type M star, then I learned later. It's slightly variable, but there's not a good magnitude range that I could find for it. But anyway, so the two stars that I saw in the previous slide are 62 and V1943 then, and there were these two little stars there that would have matched. If I had realized that, I could have quickly figured it out. Being in the field like this with simple equipment, we don't have the some of the things you've mentioned on the chat with nice star fields that perfectly match things and everything that you can easily pull up, especially on the pre-point line. Maybe should look into that a little bit more, some of the things that Ted Blank has done and stuff too. You can figure it out, but this is this shows the field of view that we had of the that's shown here, identifying with these little two stars, and of course this star was much brighter, and then the larger rectangle is the field of view of the finder scope that you the RunCam Mini that you saw in the previous slide. So if I'd had the RunCam, so one of the things I tried to use the visual finder scope with that, but the target was high enough and I just had a straight through. I should have got a right angle one. I might have been able to see better. But when we arrived at the site, another problem was that we thought we'd be at this nice end of this cul-de-sac looking over a field. It would have been perfect, except that when we got there, there were a couple of big trucks with huge lights on, trying to park this big moving equipment for the day or something for some road construction. I don't know what, but they were slowly moving around and right where we wanted to be. So we had to quickly find another place nearby, which that still had some light pollution, so that the visual finder just didn't, I couldn't see things well enough in it to really tell. But if I'd had the video finder, that wouldn't have had that problem. So, we've just used that video finder for the 16-inch, but I'm going to be using it for the maxis now in the future. Anyway, this just goes through some of the things I use Guide 8 to produce my charts. You can click on each star and it tells you the spectral type and variable name, if any, but of course that's tedious. But you can also have an option to show the star colors and show variables. That's, I'm going to keep my, the Guide 8 up on my computer. I had it on the computer, but didn't realize all these things, and now I do, and can go through and check for possibilities in the field in real time. So normally I turn off everything in the data shown menu except for the planets. Of course, want to see them, but also at least preliminary work. You can also just leave only the planets on, and also you can turn on the variable stars, and it would have been popped up, and so you could tell that something might be wrong. Another way is to show the colors. If you do the star display, you can click on the colors, and the red stars show up. But the red colors are pretty close to the orange ones, so it might not be real easy, especially in the dark, to figure that out. And so there are 2 red stars in this field and lots of orange ones, and I marked the 2 red ones here. And you'll see later this one was the culprit. So this is showing the variable stars and the colors, and showing a number of the variable stars, and I checked some of them out then to see what kind of variables there were. So I just have a number of slides pointing that out, the ones that might cause some problem. So this one, AC, Capricorni, is closer to the target, but it was it's late spectral type, and it says it's a long period star, but there's a very bright star that would have is not so much of a problem. But just talk about the different ones. Eclipsing variable is farther from the path. These ones are farther from the pre-point line, so they're not so important. And I have all of these things. Here's a big magnitude range for this for RR Sagittarii, but which might have been similar to V1943, but I didn't even notice it because I wasn't looking that far south. Anyway, this is V1943, the data that you get for it. It's a very red star. You can see the late M spectral type. It's the stars with M5 and later spectral type that really can confuse our cameras. So it'd be nice to have a star catalog that with the magnitudes that matched our cameras. But anyway, I have a couple of slides here that are just in conclusion. These are just the very red stars, most of which are variable to some extent. have deleterious effects on visual pattern recognition that we rely on for pre-pointing our telescopes. So it's important to use a catalog that identifies and appropriately characterizes givers of these stars. And but I think it might be also useful or necessary for automatic pattern recognition for automatic systems like those described by Alex Knox for this. But I think those systems, if they find a star that doesn't seem to agree with what they have, they just ignore it. And as long as they have 6 or 7 stars, if you throw out one, you can still do your plate solve and figure it out. Anyway, just some other points then, talking about Knox's presentation. I don't see why the technology that she showed couldn't be used to control larger telescopes, even like the 16-inch Skywatchers. It wouldn't be for remote station use in that case, but it would certainly facilitate getting on target, and you'd need fewer practice sessions, would really help their observers, I think, if we can get that system to work. And then finally, just one other thing I want to say, talking about SWIRI and everything, at the NASA Small Bodies Assessment Group in January 2019, Mark Bowie made a very good case for officially supporting occultation work. His presentation is given this PDF. I encourage you to read it. And professional astronomers did take notice with this and the publicity from SWIRI's 2017 and 2018 MU69 campaigns. So the word is getting out that occultations are cool and they're useful. What I'm getting to here is that there's a cycle going on now to write white papers about the scientific goals that the U.S. should manage for the next 10 years. It's the so-called Astronomical Decadal Survey. Inputs for it are due in the form of white papers. They're due on August 15th for proposed space missions and September 15th for others. I think we should really write a white paper on occultations, essentially making the points that Mark Bowie did in his SBAG presentation, and expanding a little bit to get some official support for our occultation efforts, to at least make the case that this should be done and get it out there in some official way. And this is the mechanism for doing it. I've made a sort of a first draft of a white paper for this, but they're due pretty soon, so we have to work quickly if we actually do this. One of the things I would advocate is that for small body space missions, which there are several of them now, that they should allocate a small amount to support occultation efforts for their projects so that they can get occultation data on their targets, similar to what the Lucy project is actually doing now. Of course, they didn't think of that when they proposed their mission, but they're actively doing it now. And you can also make the case that occultations interact with people in different places, so they're great for public outreach. I'm also going to make the point that international collaboration is very important, since the U.S. Has only 6% of the world's land area, so you're missing 94% of the occultations if you only consider our territory. Anyway, I showed this thing to Mark Bowie, and he said he was just sort of a little bit supportive of it, but he said we need to do more than just say occultations are good. And I think I addressed that with some specific suggestions and reasons why occultations can benefit people. People are, as I say, just from Mark's 2019 presentation, people are already taking notice, and they've proposed it for things like if a threatening asteroid is found coming towards the Earth, one of the things at a planetary defense conference, someone suggested, well, why don't we just organize a big, massive occultation campaign to characterize it to see if it's a double or whatnot, you know? So, so anyway, unfortunately, Mark is tied up completely during the next couple of months with the Lucy campaigns this fall that Steve mentioned briefly yesterday. So he's not going to be able to help much with these upcoming deadlines. But if you want to help with the effort, let me know. So anyway, just to conclude this presentation, which I've taken a little too long at, I just wanted to say that Josephina occultation where we ran into that darn star, was a day after that was our 50th wedding anniversary, and here's a picture 50 years back in time. Joan showed part of that, but this is the full picture showing from left to right Tom Van Flandern, Ron Abelia, Homer DeVol, and Edward Hallbach from the Milwaukee Astronomical Society, and of course Joan and I at an earlier time. And this is the Milwaukee cable that Ed Hallbach was bringing down and giving to Homer DeVol to borrow to use for a grazing occultation that happened a few nights later. I think that's what that was. But anyway, if it were not for COVID-19, we would have had a big family reunion at our home, you know, for the anniversary, and then we would have been too busy with preparations and wouldn't have been able to undertake what we did for Josephina. So that's the end of my first presentation, and I have to I go on. If there's any quick questions, I can take them now, but while I'm bringing up the next presentation. But since I have two other presentations, I want to, you know, just go through them, and you can go towards the end of the second one. We can go more about that. The next presentation is about the faith on this one here.